Dear students, let's study isothermal and adiabatic processes. Let's first see isothermal processes. Isothermal process: when a system undergoes a physical change under the condition that the temperature of the system remains constant, then such a process is called isothermal process. For such a process to take place, it is necessary that the system be surrounded by a perfectly conducting material, so that any heat produced in the process immediately goes out from the system to the surroundings, or any heat absorbed comes from the surroundings into the system, and the temperature of the system remains constant. In practice, there is no material which is perfectly conducting. Hence, perfect isothermal process is impossible. But when a process takes place very slowly, so that heat finds sufficient time to flow, then the process is approximately isothermal. For example, suppose a gas is filled in a metal cylinder fitted with an airtight piston as shown in figure. If we compress the gas by putting small weights one by one on the piston, then the pressure of the gas will increase slowly and heat will be produced. But since the metal is a good conductor of heat and the pressure of the gas is being increased slowly, this heat goes out through the walls of the cylinder. Thus, the temperature of the gas will not increase, and the change in pressure will be isothermal. In a perfect gas, an isothermal process obeys Boyle's law, that is, for a given mass of gas, we have PV equal to constant. The internal energy of a perfect gas depends only upon the temperature. Hence, an isothermal process does not produce any change in the internal energy of a perfect gas. Now let's see adiabatic process. When a system undergoes a change under the condition that no exchange of heat takes place between the system and the surroundings, then such a process is called adiabatic process. For such a process to take place, it is necessary that the system be perfectly insulated from the surroundings. Under this condition, if any heat is produced, it does not go out from the system and the temperature of the system is increased. If any heat is absorbed, no heat can come from the surroundings and the temperature of the system falls. In practice, there is no material which is perfectly insulating. Hence, perfect adiabatic process is impossible. But when a process takes place very rapidly, so that the heat does not find time to flow in or out, then the process is adiabatic.